Okay. Thank you for attending this session. So how do you like your new Galaxy tab? So hopefully the next thing you want to do now you've got your device is to write Android applications for that device that work with Google APIs. And my goal here is that after watching this session, you should be able to get started and be able to build real applications. So let me introduce myself. My name is Yaniv Inbar. I've worked at Google for about 4.5 years, and during that time, I've worked in the Google API infrastructure team. I'm the tech lead of the team that develops client libraries for Google APIs, and also the lead developer of the Java library. And one of the key goals of the Java library is to make a great experience for working with Android applications. And I'm really excited here today because just about a year ago, I announced a prototype of this library. I gave a quick demo working in a G1. And I talked about how great this is going to be. And today, the big announcement is beta. So the Google APIs client library for Java is now in beta. And we're eager to have you try it and give us feedback how it's working for you. We've written applications based on this library, so we feel pretty confident about it. So this is our beta period, and we hope that if all is successful, we'll be able to go out of beta soon. So all the best practices that we've learned about accessing Google APIs, we've pretty much codified in this library. And I'm not going to go through every detail of what's found in the library. It covers a wide range of use cases, but I'll cover the highlights, which are most important to you as Android developers. So before I jump into the library, I just want a quick idea of the kind of experience you've had. How many of you have developed an Android application? And how many of those of you, have developed an Android application that works with Google APIs? OK. And how many of you thought the process was easy? OK, no hands are going up. I didn't think so either. And this was a big challenge. So we wanted something that was really powerful, really efficient, but also reasonably easy to use so you can get started quickly and build powerful applications. So let's first talk about what are the platforms that we're targeting with this library. Android, of course, our premier platform that we're focusing on today. But this library also really works the same way on Google App Engine, if you're writing any servlet environment or an installed application using Java 5. All those platforms are supported. And that's important to understand when you're using this library, because that theme will come often as you're experiencing the library. So what are the APIs that are supported by this library? Well, of course, Google APIs. There are actually two different categories of Google APIs. I'll go more into detail about that. Some of them are built on our older technology, the Google Data API technology stack, YouTube, Blogger, those kinds of APIs. And some of them are built on the new infrastructure. And I'll tell you about the advantages of the new infrastructure and what this means to you as developers. But really, this library is designed for pretty much any API on the web. And why would you care about that as an Android developer? Well, why would you want to use a different library with one vendor and a different library for another vendor? Ideally, you'd like a library that would pretty much work with any API and have a consistent experience. So if you're developing an Android application, you'd want to use the same library. And what are the data formats supported by this library? Well, JSON is our premier data format. It's by far the most common on the web. It works really great with JavaScript, but really does support across many languages. It's a lighter weight format than XML. XML is a more traditional format that we've used for REST APIs. The Atom Publishing Protocol in particular is based on XML. So it has a long history, and this is also supported by this library. We have support for any kind of media that you might want to use, pictures, videos. I take a photo on my Android device. I want to upload it to Picasso. That should work with this library. We really allow you to plug in any data format that you want, but those are sort of the ones that we've built a good experience around in the library. And one authentication mechanism supported by the library. Client login is the traditional username password authentication mechanism. It's managed by the Android operating system to use it with Google Data APIs. But we really support and recommend OAuth as an open authentication protocol that works across many different websites. And I'll talk more about that. And this is actually maybe the most tricky part of this presentation, and maybe the part I'm most excited about to talk to you about today. So let's break this down. Let's start with the platforms supported by this library. If you don't mind, I'll go extend beyond Android for a moment. So a key design goal of this library, we want to make sure that will work across any platform based on Java 5. So we want to be platform neutral. That means we can't take advantage of maybe some hooks that are in the Android SDK. But the advantage of this is that now we can make sure that we can work pretty much the same way. If you see a library that was developed for OAuth 2, you don't have to worry about, based on this library, you don't have to worry about, well, is it going to work on App Engine? Is it going to work on some other environment? The library works the same in all places. And the only way we were able to make this happen is by making everything pluggable. I can pick a different HTTP stack. I can pick a different JSON library, pick a different XML library. Authentication, I should be able to use any one I want. So that's a key design principle here. So let's take a look at some code. And I'll warn you, you're going to see a lot of code in this presentation. This is a 201 level session. I won't be able to go into all the basic details, but I really want to make sure that you'll be able to just write some code directly after watching this presentation. So here's what it looks like on your normal Java command line application. It has the main method, and there's this buzz object. This is part of our generated libraries. I'll talk more about that. But I'll point out one point of confusion here in this presentation. If you're an Android developer, you're very familiar with activities. Those are your main UI components. Unfortunately, Buzz also has activities. So I'll try to make it clear based on the context here, what I'm talking about. But basically, your Buzz, Google Buzz, I hope most of you are familiar with it. It allows you to post your activities. You can download other people's activity stream. You can make them public. You can have them shared. In this case, I have an example of someone's public activity stream. It's a demo account. So you call buzz.activities.list. It returns an activity feed. You have to check for null there because there may not be any public activities as for optimization. But in any case, we just iterate over it. This is just basic Java programming and print it out. So hopefully really intuitive and hopefully pretty readable. So let's look at what this looks like on another platform, on App Engine. So I'm extending HTTP servlet, and there are a couple minor differences, but mostly this is the same, right? So we've got the Buzz object that manages your anytime you're working with this library, and again, the code below is pretty much the same. So I want to highlight one really important difference here, though. The parameters I passed to the Buzz object. You notice I'm using URL fetch transport. That's the ideal one to use when working with Google App Engine, and it's only applicable to App Engine. And I'm using Jackson Factory. That's based on the popular Jackson JSON library. And if you don't mind, I'll skip back to the previous slide for a second. Here I use net HTTP transport. That's based on JavaNet HTTP URL connection. So that's the one that's applicable. But that's pretty much the only thing that changed here. I'm also using Jackson Factory in this case. So if you don't mind, I'll jump now from App Engine to our premier platform, Android. If you've done any Android programming, this is pretty basic Android list activity class. It just gives you a list box of all the activities from this person's public stream. Nothing new from the perspective of Android programming. I am doing some bad things. Maybe you can notice it on this slide, and I'll talk about what's wrong with this picture. It works, but there's some things that are not quite the best designed. So I'm downloading a list of Buzz activities. And then I'm converting each activity content into HTML, and that actually displays this nice HTML content. So pretty simple Android programming, and mostly the same in terms of look. I am using the HTTP URL connection, and I'm using Android JSON Factory. This is maybe not well announced, but if you look in the Android SDK, there's now a JSON library that's actually streaming. It's really good, so that's what I'm using here, and I'll talk a little bit more about that later. So let's talk about the pluggable HTTP stack. I showed you some examples. The biggest difference between them was which HTTP transport I've used. So URL fetch transport, that's the ideal one to use in App Engine. If you're programming for Android, you have two important options. One is based on HTTP URL connection, which is, if you're familiar with any kind of Java programming, that's part of Java, it's part of the Android SDK. And also, the second option you have is the Apache transport. That's based on the popular Apache HB client. And that's not part of the Java, but it is part of the Android SDK. At least for now it is. So the question is, well, which one should you pick? And the answer is a little tricky. I talked to an expert in the Android team, and he tried to explain it to me. Basically, they fixed a whole bunch of issues with the implementation of HTTP URL connection in Android in the Gingerbread release. And you may or may not encounter those, but it's best practice to just use that one. It's really the one that they've developed the best. So highly recommended if you're targeting Gingerbread or later, use that one. I'm not sure how good a support they will have for the Apache HTTP client in the future. They still both work, but that's what's recommended. But if you're working with a previous version of the Android SDK, you'll want to still use Apache Transport, just to avoid those few bugs that they fix in Gingerbread release. So if you're targeting both the Android SDKs, I create a little utility library that just does if Android level greater than or equal to Gingerbread, use one, else use the other. OK. So let's talk about the library and how you make requests. A lot of times, every request you make, you'll do a lot of the same things. I want to set the user agent string to, this is the application name. I want to set the GData version. When you're working with Google Calendar, you have to specify what version of the API you need using a header. That's something you need to do. If you're writing any real application, you just have to do those things. You need to enable gzip if you want the most efficient posting of content. So there's an example here of how you use the request factory. And the request factory is nice because it lets you do a bunch of consistent behaviors across every request that you make. And there's some more sophisticated functionality in it that I'm not demonstrating code here, but you can have code run before you execute any request. You can have code run after you get an unsuccessful request. So why are these in the library? Well, for OAuth is a great example. OAuth 1.0, for example, requires you to sign every request. So that's how you can build a hook. Every time before you execute a request, you just sign the request using the OAuth 1 specification and go ahead and make your request. And don't worry, we'll make this a little bit easier for you. Stay tuned. So I wanted to put this little tip in here. I don't want to dwell on it. But if you've done any kind of programming with making HTTP requests, it's really nice to be able to log the requests and the responses that you make. So if you set the logging level to config, you'll see those requests. I did one thing is that I'm not showing the authorization header by default if you set to config level. So if you set to all level, then it'll show the authorization header. This is maybe to avoid some use case if we don't want to log the most sensitive data. But the one trick on Android that's really important is you need to also set some property here. You're probably not going to remember exactly the command to run, but when you go home, write your application, you can come back to the slide. OK, so let's step away from the mechanics of making HTTP requests and think a little bit more of the bigger picture. How do you actually design your Android application? So the most important principle that I hope you remember is you don't want to make HTTP requests in the UI thread. If an HTTP request is fast and you got a fast Wi-Fi connection, great. But if it's anything like the experience here at this conference, Wi-Fi is not always fast. It's not always reliable. That's a reality you have to deal with on Android devices. So don't make any HTTP requests in the main thread. That was a mistake I made in the first sample code I showed you. One risk is if the Android operating system sees, OK, your application is hanging. It's not doing anything. It's going to put up a dialog box, a scary dialog box saying, hey, your application's not responding. Do you want to shut it down now? OK, that's not good. So the simplest solution is to just use async task. And I'll give an example in just a minute. But before I show you that example, I highly recommend there's a great session from I/O last year called Beginner's Guide to Android, which really covers this in detail and shows you how to use async task. So here's an example. I tried to squeeze all that code into the slide. I apologize. But basically, the top of it is pretty much the same. I'm extending list activity. But then I'm using async task. I declare a class called load activities. And I've got a progress dialog. So it'll show a nice little circle saying loading your activities now. And then there's this method called do in background, which Android takes care of all the thread synchronization for you. So if you don't know a lot about multi-threading, this is a really great tool. You don't have to worry about making sure that the memory is properly synchronized. So the implementation here is pretty simple. One line of code. I execute the request using the library, and I return the activity feed. And that activity feed is passed to, next slide, on post execute. So it takes an activity feed and pretty much does the same UI code that I showed you earlier. And maybe some of you, this is boring, you've already seen this before. That's great. If you haven't seen it before, please try it out. So that's async task, and it's relatively simple. But let's say you're building a more complex application. In my case, I'm just displaying a bunch of buzz activities. Worst case scenario, I lose those activities. I can always make another request and get a new one. But a lot of real applications require you to do something more sophisticated. So a better design that deals with more complex use cases is to actually use a background service. And I won't go into details. There's actually an excellent session from last year's Google I/O that I really enjoyed that shows you a lot of the different options for how you can do this, called Developing Android REST Client Applications. I'll just summarize the general principle, which is you're going to have a background service running on the device. It's going to store the result of the HTTP request in a SQLite database. And then it's going to talk to the activity in the UI thread, give it back the response. But activities have a life cycle. There's no guarantee that, that the activity is going to be there when the response, maybe the user got a phone call, and, or maybe they want to play Angry Birds. I'm not sure. The Android operating system might decide, you know what, I'm running low on memory, let's just shut down your application. Whoops, we just lost some data. This is going to be especially crucial in some cases. So the key thing you need to do is when the activity starts up again, OK, check if we have any new data, load it up, we're good. So I want to talk about something that I see often, complaints from developers. I download this library, I run in the device, and it's 2.3 megabytes. My little example here. Something is wrong here, right? Why would you take a 100 kilobyte example and then up with a 2 megabyte library? So there is something wrong here. And the trick is to use ProGuard or any other tool that shrinks your application size. But ProGuard is a particularly good one, and it has a good support in the Android Eclipse integration. So that's why we're recommending that one. And you'll see in this very complex graph, with ProGuard, without, which would you pick? 123 kilobytes versus 2.3 megabytes. So what does ProGuard do? What's the magic behind it? Well, the first thing it does is strips out any unused code. Right? So I want to use this 1 megabyte library, but I just need this one method. Is that OK? Well, normally not. But when you use ProGuard, yes, it's OK, because it'll only include that one method, not the rest of the 1 megabyte library. And actually, that is what we're doing. We're using Guava, which is a very large library, but we're just using a tiny bit of it. So it should work if you set up your ProGuard configuration file correctly. Now, one more note about ProGuard is it also does a lot of other aggressive optimizations. It changes your class names to single letters and all sorts of crazy stuff. You can disable that if it's too aggressive of an optimization. Really, the crucial thing is to cut out anything you're not using. But you're welcome to play around with it. So how do you set it up? The number one mistake people make in setting up ProGuard is forgetting to add this one line in default.properties file. I highly recommend the Eclipse new project wizard. It generates a ProGuard configuration file for you that's actually pretty good. And it generates a default.properties file. You just put in that one line, ProGuard config. That will tell it to run ProGuard. And then I added some more lines in here. I'm not going to go into detail how they work and why they're important. But suffice it to say, you just add these few lines, and they're really crucial for this library in particular. Not for Android programming in general, but for this library, you absolutely need these. Otherwise, it's just not going to work properly. So when you run your program in debug mode, it will actually be the full 2.3 megabyte application. That's OK. But then you want to make sure you run it in release mode. And sometimes people forget to do that. I've done that often. You run in release mode and see if any bugs happen. As I said, ProGuard can be aggressive sometimes, so make sure that the things that you expect to work are still working. All right, so let's talk about the next section of this session. What APIs are we trying to support with this library? Well, my vision is ideally all of them, so let's talk about them. So Google Data APIs are by far our most mature platform. Some really popular examples: YouTube, Calendar, Blogger, the contacts. Those are some of the ones that you'll often see being used. They have many years of experience behind them. It's a great architecture, but there are some flaws in it, and I'll talk more about what those issues were. But first, one of the main principles of this platform is it's a decentralized architecture. So YouTube has its own server running, Blogger has its own server, Calendar has its own server, and they both all using the same GData library. But because it's a decentralized architecture, we didn't have as much control. So we added some features to one, they weren't always there in the other. And that was one of the problems that we tried to solve with the new infrastructure. Another issue with the Google Data API's infrastructure is XML, and it's a great data format. We were using the Atom publishing protocol. It's standards-based. It uses REST as its primary principle, which if you're not familiar with that, that's when you're making only basic operations. You create, you update, you can delete objects. So very easy to understand. However, XML is a more heavyweight data format than, say, JSON. So we designed this new format we called it JSON-C. Unfortunately, it's only read-only. Picasa and YouTube and Calendar are some of the few APIs that implemented it, and it's great, but as I said, decentralized architecture, we couldn't do it across all of our APIs. The authentication mechanism supported, I'm going to go into a lot more detail, but client login is a great choice for Android programmers. It's not such a great choice for other types of environments. So OAuth 1.0 and OAuth 2.0 are the authentication mechanisms you'll want to use in any other platform for right now. So we actually have a Java library for Google Data APIs. And it's pretty good. It has a nice XML data model. I actually had a role in designing that data model. And it's code-generated, actually. But there are a couple of minor issues that might worry you as an Android programmer. One is it only works the Google Data APIs, which is OK right now. But as Google comes up with new APIs, as I said, they're all going on this new API infrastructure. So too bad. And another minor problem, it doesn't really work well on Android. You'll get an exception if you try to use it. And we think it might be fixed in Ice Cream Sandwich SDK. I heard from one of the Android programmers they fixed that one bug. But really, at the heart of the problem is it really wasn't designed for Android at the beginning, from the start. It's not efficient. It doesn't think about the use case that you want to think about as an Android developer. So we don't recommend it. But yeah, it still exists. It's still maintained. It still works. But we haven't touched it for about 2 years now. So let's talk about the new API infrastructure and tell you why I'm excited about it and why we've really focused all of our energies and make sure it's really well supported in this library. It's a centralized architecture, really important because we can roll out new features and they work across all the APIs. We focus on JSON, which is a lighter weight format. It's more natural to use. It's a much more pleasant experience. OAuth is our authentication mechanism for almost all of those APIs that we support with this platform. And some examples, okay, Buzz, Latitude, Search API for shopping is a relatively recent one. You'll see new ones being rolled out quite at a reasonable pace now. So if you want to get more details, I highly recommend 2 sessions. One is a session from last year called How Google Builds APIs that really talks about our new API infrastructure and the vision that we had a year ago, which thankfully hasn't changed at all. We've just simply rolled out on that vision, executed that vision. Actually make a quick appearance on that video. That's where I talk about the alpha prototype of this library. And the second one that I highly recommend if you really want to get a beginner's view of working with Google APIs, I highly recommend Life of a Google API Developer. Unfortunately, you just missed it. But when you go home, find it on YouTube and watch that one. So, announcing today, the Discovery service. And the geek in me is really excited about this. This is really cool. We just announced on a blog yesterday. It's basically a directory of all the APIs on the new Google API infrastructure. And you get a discovery document for every API that tells you what are the methods that are supported in these by each API. What's the schema, the JSON schema of the objects that are being manipulated by this API. So you can think of Buzz activities, that list. That's the method. Activities feed, well, that's your object. and also the OAuth 2.0 scopes. And you'll see us really focusing on OAuth 2.0 as a premier authentication method. So there's a really great session if you're interested in this discovery service, building custom client libraries for Google APIs. I believe it's tomorrow afternoon. Check your session guide. So what can you do when you have a discovery API? Well, the first thing we thought of is let's build an API Explorer. It's a web-based tool. Now I'm going to brave and attempt to run this real quick, see if I've got the internet here. OK. So we have a list of all the services. And let's pick Buzz, activities.list. And you'll see it tells you a description of everything you need to know. For the user ID, I'll pick @me. For the scope, self, that's a good one. Execute it. Whoops, I'm not authenticated. Let's try that again. I'm authenticated now, apparently. Aha, it works. Now, why is this useful? I can see the authorization header. I can see exactly the request it made. I can see the response. I can see the data format. Wow, there's a lot of data here. Wow, I just wanted the activity content. OK, here we go. So here's the activity content. I'll come back to this in a second. OK, so this is fun. This is just a great tool if you're doing any kind of Android development. So let's go to the next tool the next thing we can do with discovery. Well, we've got the APIs console, and I highly recommend the session that just ended momentarily. This is about setting up which APIs you want to access as a developer based on this new infrastructure. It's about getting your API access key, which is going to be important later. I'm not going to show you a demo of that. Well, I can show you real quick what it looks like. Here it is running. So let's say I want to use the URL shortener API. That's a fun API. OK, it's on now. Great. So I get a free limit of 1,000 queries per day. If I go beyond that, I'll probably have to pay for that usage. But that's a pretty high limit. You can see I've already enabled Buzz API. If you go to the API Access tab, you'll actually get your API access key. And it will look something like this with the API key not blocked out. Sorry. And so I'll come back to this later in the presentation. OK, so what's the next thing we can do with the Discover API? Well, actually, last year, immediately after the Google I/O session, I had a developer, I don't know if you're here in this room now, but come up to me and say, hey, wouldn't it be great if you took the Discover API and generated a bunch of libraries based on that? And I said, you know what, that's a great idea. So 1 year later, we're proud to announce we've got generated libraries based on Discover API. So here's an example of how you can use it. I already showed this earlier, Google Buzz, getting activities list. I have here an example of inserting an activity. So this is based on the JSON schema. We can just generate Java classes right out of it. So I do new activity. I set the activity content. And I call the Buzz activities.insert method. I get a result back. Pretty straightforward, pretty readable. How do you delete an activity? And I'll give you one hint here. I always forget to call a .execute method. You're calling .delete, and you think, oh, that's going to delete my activity. Oh, I forgot to call execute. So don't forget that. OK, so we've got generated libraries. So this is what gets me excited about this new API infrastructure. We're able to provide this to you, make your life a lot easier. You don't have to write your own HTTP request initializer that sets the GData version. It just works. All right, so what are the data formats supported by this library? This is going to get more detailed than we've had before. So JSON, I talked about how great of a format that is. It's lightweight. It's well supported across different platforms. But here, I'm again going to give you a bunch of options. Let's allow you to plug in any streaming library that you want. Now, why a streaming library? Why not just use JSON object? Android devices often have very low memory. So what do we do about it? We can use JSON object. That's part of the Android SDK. And that usually works. The problem is it loads everything in memory. You want to avoid that. Suppose they get that activities list. Do you remember how I showed you that response? I had to scroll many pages just to find the information I wanted. So that's going to be a problem. You're likely to get an out-of-memory error. Whoops. So the way you solve it is you use a streaming parser. You're really getting every little JSON bit at a time. Get me the next field, get me the value, get me the next object. So it's very low level. It's not that easy to use, but it's by far going to get you the fastest implementation. And given that this is a best practices session, I want to make sure you're doing the right thing, you're building your application the right way. It's your choice. Do you want ease of use or and very quick programming, or do you need, you're running a very critical section of your application and you need that speed? So regardless, here are the choices you have for the JSON library. You can use Jackson based on our tests that we found to be the fastest choice. It's based on a popular Jackson library. Another option is to use Google JSON, which we found is pretty fast, not quite as fast as Jackson, but pretty good. But it's a lot more lighter weight. I think Jackson's somewhere around 180 kilobytes. JSON is somewhere around 20. I don't remember exact numbers, but that's roughly the scale. So if you're really counting every byte, you might want to choose Google JSON. If you're building an Android application, that's probably an important consideration for you. A trade-off for you to make, you choose. Now, as I mentioned on Honeycomb, and starting with Honeycomb devices, they actually have Google JSON built in. It's in the Android UDL package. And if you're writing an application that targets Honeycomb anyway, you might as well use the Android JSON factory. Why not just use something that's built into the Android SDK? That's going to be definitely going to minimize the size of your application. And of course, it's part of the Android SDK. It's probably going to get developed in the future. If there's any way to make it faster, they might do that. So let's talk about the data model that's part of the library. I talked about the streaming parser. Let's talk about data models, and I'll come back to the middle later. So this is functionality that's very similar to other libraries out there. I don't want to claim this is the only library that does it. Jackson has a great object-to-JSON mapping. Google JSON has one, and now we do too. And the reason we had to build our own is because we wanted to work not just with JSON. We wanted to work with XML. You could do the same thing. You want to have a data model for URL query parameters, for request headers. You'll see this across the library used in a lot of different contexts. Well, let's talk about how it's used with JSON. So the idea is you have a Java object and you have the JSON. So you want to, every time you see a Java field of type string, it maps to a JSON string value. Numbers, Booleans, they're supported. You can use enums to map to string values in JSON. You can use arrays and collection. That maps to JSON arrays. You can use, if you've got a JSON object, that can be either mapping to a Java object or a Java map. You can use the full richness of Java with this library, list of activities, generic types. Pretty convenient. So I'll give you a handy tip when you're getting to more sophisticated usage of the library. Sometimes you only want a few fields, and you can only declare those fields, and it'll basically ignore everything else. So I showed you that long example of a buzz activities list. Well, I just want the content of the object. Well, if you only declare that one field, it will basically drop everything else. It'll make it faster and use memory more efficiently. But sometimes you need to preserve content that you don't need. And the reason for that is, a good example for that is when you're using the put method. So the idea is you get a buzz activity, you change one thing about it, and then you post it back. You put it back into the buzz activity post. And the important thing is if you drop the data that you don't recognize, that you're not using, Buzz is going to think, oh, that means you want to delete that data. Whoops, we can't do that. So you absolutely have to preserve everything. Again, trade-offs. With the put method, that means that you are keeping a lot of stuff in memory or maybe in your database that you didn't want to preserve. So those are the decisions that you would want to make. And by the way, if you're using the generated libraries, we already provide a full data model for you that extends generic JSON. So oftentimes you won't have to write this, but if you're really optimizing for efficiency, you may want to do the extra work of writing your own data model. Or if you're working with something that's not built on the new Google API infrastructure. OK, so here's an example of the JSON model. I won't go into a lot of details into it. It's hopefully pretty self-explanatory. You've got an outdated key, an ID key that maps to update and ID fields. Datetime is something that's part of the Java library. It just represents dates. You've got objects within objects. The key here is the @key annotation. That's what tells the library to preserve that in the JSON. So let's talk about how to make your app more efficient not just in terms of application size, but let's talk about the HTTP response size. So you already saw in my example that was 7 kilobyte response. That's not a great choice. Again, Android devices, maybe the user is paying for the amount of data that they're getting. You want to make your application responsive, so you want to make the response size smaller. A full response, 7 kilobytes, when you're using gzip, it'll be compressed down to 1.3 kilobytes. So that's actually already much better. I guess that's 7 times better. But that's not good enough, because you're still getting all of that content. I really only want to get the content of the buzz activity. So if I tell it to do is just if there's a special partial response syntax, it will just get that one field. And I'll show you that in the next slide. But you end up with a 286 byte response. That's a lot better. So order of magnitude difference just by using it. The library will automatically gzip things for you, but the partial is something you have to do yourself. So here's an example of using partial. I took that one line of code that we had used in many examples before, and all I did was add a fields mask. So request.fields equals item/object/content. Pretty straightforward in that simple case. You might have a more sophisticated use case. Maybe you want also the updated and the ID fields. OK, use the parentheses syntax, comma separated. Not too bad. It's something you have to learn, and you'll only want to use it when you've got a critical section of your application that's running slow. But it's a great tool to have. So I mentioned earlier, it's not a good idea to load everything into memory. And I broke that rule. Because now I've got this activities feed class. You remember in my example, when I was using async tasks, they return an activity feed. So again, I'm making the same mistake I told you earlier. Don't load everything into memory. That's generally a problem. So how do we find a middle ground between using a stream parser and using a full model? So you'll notice here that one thing I changed at the top is I'm using execute unparsed. So that's going to return the HTTP response. And I can just do get content, gives me an input stream. I parse it using the JSON stream parser. I go to data, I go to items, and then I parse each object separately. And I'm doing this, I'm parsing the activity class. So I'm still doing a full representation of an activity, but it's a much smaller representation. And what I forgot to add in here is the partial fields mask to make it that much more efficient. Right? So this is maybe the best compromise. If you've got a critical section, you want to stream at the level of entries. So for each buzz activity, parse that one. So let's jump real quick to XML. Now, XML is a bit more work for 2 reasons. One is XML namespaces. That makes it more work than JSON. And the second is we don't actually provide you with a data model for Google APIs built in XML. So I won't go through all the details, but you'll see the gcal namespace is in there. So we have to specify in the @key annotation, this is the XML name that I want to use. And another trick here is the @type. That stands for an attribute. If you're familiar with XPath, you should be very familiar with this syntax. And if you want the text content of an XML element, that's text with open and closing parentheses. So some tips. Don't forget the XML namespace dictionary. You have to declare the namespace in advance. And why this is important is because if you are serializing an XML object, so a Java object into XML, you need to know what the XML namespaces are. There's that XML-NS declaration at the top. So you have to specify them in advance, and the library will warn you if you're not doing that. You just need to look up the XML declarations. So how do you get a feed? So we provide a utility in the library that, given a Java object, will give you that partial fields mask. And that works right now only with XML. So you call Google Atom.getFields4, you give it the feed class, and it'll just compute it for you. You can also specify it yourself. Sometimes it doesn't work correctly. It tries to guess exactly what your intent was. If that doesn't work for you, specify a string directly, no problem. I won't go into too many more details. So what about media? I get a lot of questions. How do I upload a video? I took a picture. I want to send it to Picasso. How do you do that? Or maybe I want to download a picture. So you can use HTTP request.getContent. I used that earlier. That gives you an input stream. Pretty straightforward. And the content type is the media type. So how do you upload media? Well, use input stream content. That's part of the library also. Let me show you an example. It's a little complicated, And you don't have to understand all the details. But so in this case, if you take a picture with Android, it starts an intent to say, OK, I want to upload this picture. Who can handle this? And your activity says, I can handle it. So the user picks your activity. And then it goes to the onCreate method. You get the intent. And I'm not going to go into too many details here. But the intent has information about the URI for where to download that media from. From that URI, we can get the content, the input stream. We can get the type, the media type here. That's image/JPEG or a video. And we can get the size of the content. So all these pieces of information, you put that together. You send it into the Picasa API. You set the appropriate headers. There's a slug header in there also. And you execute the request. So you have an example how to do it. It turns out that there's one problem with it, though. Because we're posting a huge media file, potentially, this might take a long time. And there's a protocol called resumable upload, which I don't have time to go into here. But that's something you're going to want to look into. That's also supported by the library, though not as well as we hoped yet. OK, so now for the part that is maybe the most exciting of this library, and not quite completely figured out yet. So the most important thing you need to know about authentication on Android is the account manager. User accounts are centrally controlled. You don't want to come up with your own flow. I've come up with a bunch of them myself, and the Android team told me, don't do that. It's bad. Don't tell people to do that. We have to make sure you're always using account manager. Nice thing about accounts is they can be synchronized. Your Gmail is downloaded, sort of happening in the background. A lot of cool things you can do with the account manager. So what is the account manager really? It's an abstraction. It has this concept of an account and a concept of an auth token, but it doesn't really specify which account that is. So it doesn't work. It works with Google accounts, but it works with other kinds of accounts as well. So the key two things you need to know: what is the account type, and what is the auth token type? With Google accounts, the account type is always com.google. So that's simple. The auth token type depends on which authentication mechanism you're using and which API you're talking to. And there's a little useful utility in the library called Google Account Manager. All it is pretty much the same as Account Manager, except it knows what the account type is already. So client login. That's username, password. It works great with Google Data APIs. And as of right now, that's the best you have when you're working with Google Data APIs. The biggest problem with the client login for you as a user, as a developer, is it's not supported by the new Google APIs that are coming out. Buzz, Latitude, they're not going to accept the client login token. But it works great with YouTube, Calendar, Blogger. That's what I'd recommend to use for them. You request permission from the user. That's done by the operating system. We don't want to see anyone writing an Android application that asks the user for their password. That's really bad. Who's going to trust an application to give them their password? So the auth token type is also called a service name. If you ever look in the client login documentation, for Google Calendar, it's called CL. Here's an example of what the user interface looks like. It says, do you want to give your Google Calendar access to this application? In this case, it's the calendar sample. Hopefully, they click Allow. So here's what it looks like. This slide is pretty much the same as the previous slides. I have to set a request initializer that sets the GData version. The one thing that's new here is I'm calling headers to set Google login. So the auth token that you got from the account manager, that's the one you pass into the header. I'm using Google Account Manager class. I am preserving the auth token and the account name in the shared preferences. That's for convenience. You don't have to do that. But it tends to make for a more friendly user interface flow. I figure out if I have the account by that name. If there is one, I can just go ahead and load the calendars. And that's going to use an async task, like I've shown you before. But if there isn't one, you call the choose account method. So let's see that one. Choose account method uses my favorite method from the account manager class. Get auth token by features. Now, why do I like it so much? It takes care of a lot of stuff for you. If there's no account set up, it'll go through the setup a new Google account setup flow for you. Great. If there is an account set up already, or if they went through the flow, it's going to put up that permission dialog, and hopefully the user clicks Allow, and it will get the auth token for you. So all you have to do as a developer is implement this Account Manager feature, I get the account name and the auth token, and I load the calendars. If there are multiple accounts set up on the device, that method will always take care of putting up a dialog box that says, OK, which account do you want to use? So very convenient. Now let's talk about OAuth 2.0. And I'll warn you that not everything here is as pretty as client login was from a developer's point of view. But why do we love it as authentication mechanisms? It gives the user a lot more control over the amount of data that they give the application. So one nice thing about OAuth is it allows you to specify a scope of access. Do I want to give full read-write access to Buzz, or do I want to give just read-only? Do I want to give access only to the photos? So scopes are very convenient that way. Maybe your user is more likely to use your application if the permissions that they have to grant you are not as scary. Another thing to know about auth tokens is they are temporary. You don't want to be sharing your auth tokens widely, and OAuth takes care of making sure that those tokens expire. So an hour later, they won't work. Users would love this because of the security implications of this. As a developer, that makes your life more difficult because you have to handle an expired token. So how do we do that? And another important thing, you check for 401 error response. And another important consideration, how do we get the auth token for OAuth 2? There's nothing in the documentation. So what I'm going to show you is not documented yet. This is hot off the press and not ideal yet. And the reason we haven't documented it yet is because it doesn't work quite as well as we'd like it to. But I want to show you long-term, this is what you need to be doing. Use a special auth token type, OAuth2:scope. Sounds simple, right? It works just like client login. The only thing that changed is the auth token type. We're going to improve on this story later, but here's how it works right now. So the user interface says, do you want grant a permission to this application called OAuth2:, etc. Not the ideal user experience. So how do we solve that? Well, we don't have a great solution yet. For Google Buzz, you can use a special alias Google Buzz. Then it will actually show Google Buzz in this permission dialog. So that's great for Google Buzz. It gives you read-write access. What happens if you want to use a different API? Well, we're going to try to set up more aliases for you. That's our quick and dirty solution. Will come with a better long-term solution later. There's another problem here. This OAuth 2 flow gives you anonymous unregistered quota, which for a lot of the new APIs and based on the new infrastructure, that's pretty much gives you nearly zero quota. It's very small. I tried it this morning. I got about 10 requests out of Buzz before it gave me a 403 error. You've made too many requests today. OK, that doesn't work. So how do you get around this? Well, I remember earlier I showed you the APIs console. That's why it was so important that I showed you that console, is because you can go to the API access tab and get an access key. That gives you a very large registered quota. I think it's about 1 million queries per day. That's definitely something you can work within the bounds of for Buzz. And for each API, it's going to be a different story. So you should be able to use it. I won't have time to go through all this code. But a lot of things are very similar. The number one thing I want to highlight on this slide is Buzz.access key equals, that's what you got from the API console. This is a fake one. And the second thing you need to know is you've got another case here. What happens if you got an account but no auth token? This will likely happen if your auth token expired. So here's another slide that shows you how to deal with that. I checked for 401 error code. I invalidate the auth token. That means telling the account manager the auth token no longer works. I need a new one. And you preserve the fact that you no longer have an auth token, and you call get auth token for an account. You're using the get auth token method from the account manager. It will give you back an auth token, or it will give you an intent to display the user permission dialog. I'm sorry, I don't have to go through the time to go through it slowly. And you call on activity result. You get that token from for the account. You have to go through that flow again. So let me just quickly summarize what we talked about. The new Google APIs client library for Java, it supports a variety of platforms. It supports a variety of APIs. It supports a variety of data formats, and a variety of auth mechanisms. So in conclusion, I'm excited to have you go play with your devices, build applications, try it out, give us feedback. We're now in beta. We have a developer's guide that's custom designed for Android, And if you have any questions or comments, there's a support page that links to where you can give us feedback. And for this particular session, if you want to give us feedback, there's a link down there, and there's some Twitter hashtags to use. So that's it, and I'd like to hear your questions. So we've got 2 microphones there. If there are any live questions, please come up and ask. And I appreciate all of you staying up here so late, knowing that lunch is competing with this session. So.
So you're talking about using AccountManager, but that's only available with Android 2.1 and on, is that correct?
Yes.
So what do you do with devices that are still running 1.5, 1.6?
Good question. So the question is, the AccountManager only works on Android SDK 2.0 or 2.1 or higher. What about older SDKs, 1.5, that nice G1 phone? Unfortunately, there is no AccountManager there. It represents a very small percentage of the user base. There's actually a great page on the Android page that says what % of users are actually in that SDK. So the one good news about the story is long-term, this will work itself out. But unfortunately, I don't have a good answer for those early SDKs. Good question.
There's a lot of good code on the slides. Are they going to be available anywhere?
I'm sorry, repeat your question?
There's a lot of good code on the slides. Are they going to be available somewhere?
Yes, absolutely. I'll make sure that the PDF of this presentation will be available. I know there's a lot of content there. I don't expect you to memorize it all. I just want to make sure it's available to you when you need it. Furthermore, we'll be providing samples. We haven't yet published them, but we will be providing samples for Android for different APIs that you can play with.
Where should we look to find the PDF that you publish?
Good question. I believe it's on, when you go to the Google I/O page, you'll find it there. I'm not sure. And the presentations are going on YouTube. So if you... She says they might be there tomorrow. I'm not sure, but it should be pretty quick.
So I have a question for the OAuth 2. You say the OAuth 2 is not really ready. So as a developer, should we just wait until it's pretty mature?
OK, excellent question. Is OAuth 2 ready for developers to use? OAuth 2 in general is absolutely ready. We highly recommend, in general, that developers use it. The problem is the OAuth 2 flow on Android is a problem. The full story is not yet figured out. What I showed you works. It's not ideal. I just wanted to let you know what the state of things are right now. I don't know what the right answer for you. When I talk to some people on the Android team, they're working on different ideas of how to simplify this flow and how to make it a better experience. I don't know what's coming in the future, but I do definitely can show you this will work right now. It's the only good option you have for working with Google Buzz or any of the new APIs.
Okay, so for honeycomb development, I think I just leave it to OAuth for now, right? Not the OAuth 2.
Well, there's actually OAuth. I didn't mention this, but it works pretty much the same way as OAuth 2. The only difference is you do OAuth : instead of OAuth 2 : but again, it has the same exact limitations.
Okay.
It will work. I'm eager to get your feedback on your experience with it.
Thank you.
I have a question about sort of best practices for testing with this stuff. I'm thinking use devices with smaller amounts of memory so you find the memory issues and use a broad variety of devices. Would that be your take on this?
That's a great answer. So the question is, how do we test applications built on this library? One idea is to use a variety of devices with different form factors. You want to use different memory limitations. You want to make sure you are using different network connection, a slow or a flaky connection. How does it work there? The error conditions tend to be the trickiest. The auth flow tends to be tricky to get right. There's a lot of edge cases to test here. I wish I had a more comprehensive answer. Maybe we should actually write a good testing guidelines. That would be a great idea. We should definitely take that.
Okay, thanks.
Good feedback. Thanks.
First, this all works with the Google Documents List API, yes? And then in terms of authentication, if the user is using two-pass or two-stage authentication, is there a best practice for that? Is that
Okay, so good question. So the first was, the Google Documents API, that's actually the #1 API that I've gotten requests for with this library. So yes, it's definitely supported. Now, the next question was, what happens if you got two-factor, I forget what it's called, two-step verification set up? The answer is different for older Android SDK as it is with Honeycomb. So prior to Honeycomb, I don't think it worked. But with Honeycomb, it works now, but it's cleverly hidden in the user interface. I just discovered it recently. At the very top right corner, there's a little button that says authenticate using a web browser instead of the username password box. And I think it's only available on Honeycomb. I'm not an expert on this topic, so I'll qualify that statement. But that was what I actually did manage to get it to work. I had an account with two-step authentication verification set up. I went to the web flow, and it's a typical authentication flow you see in Google. You click submit, and then it goes back and it uses that. So it actually does run OAuth under the hood, which is really great, but it's a very different kind of OAuth than the OAuth I'm talking about in this talk.
so? For the older APIs, they would just have the user would have to get an application-specific.
Yes,
Whatever
thank you.
code.
Actually, I forgot to mention that. That's actually the most important thing.
So
Get an application-specific password.
So
So your user has to go through that flow and type it into their device, which is not a pleasant experience, but fortunately, they only have to do it once.
Thank you.
But thanks for that question.
Hi. I think my question is kind of answered in that previous response. But basically, is this library going to handle if you want just general authentication? So not necessarily that I'm using Google APIs, but for example, like on the web, I use OAuth for logging in, and I make a attribute exchange call and stuff like that. Would that be available via this library? As far as the information that you get from attribute exchange, or is it that it's going to need to go through the web flow?
Let me see if I understand your question correctly. So we talked about Google APIs and the authentication methods that work with Google APIs, but suppose you're working with a different API with a different authentication flow. Does this library support different authentication flows? Is that a fair summary, or?
I guess it's just using the Google authentication without necessarily leveraging an API per se, but just using Google authentication.
Okay. Yeah, so leveraging Google authentication. Yes, so the goal of this library, the vision is you should be able to build any kind of authentication as a mechanism on top of it. The problem is on Android, we want all authentication flows to go through the account manager. So if you don't want to use the ones that are built in, you will have to write your own account provider for the account manager. So another company might want to provide account management for their accounts. They'll just set up an account provider, an account manager, and as long as they stick with the idea of an auth token type and an account type, they can implement the account provider that gives you an auth token. And so you can pretty much implement any kind of authentication mechanism as long as it follows that abstraction.
Okay.
Yeah, good question.
Any status on Google Cloud Print APIs?
I'm sorry, can you repeat your question, please?
Yeah, any status on Google Cloud Print APIs? It's not in the list.
I don't know the answer to your question. I can follow up later. So I don't know if there's a Google Cloud Print API.
So I have one question. Like if there is an enterprise app and then which has to use the account manager authentication, can they leverage the Google API methods, or can they extend it and customize them?
I'm sorry, can you repeat your question, please?
So like the enterprise app, if it has, like there's a authentication mechanism is different, right? So it has to go to the enterprise backend. Can they use these APIs, those apps?
I don't know the answer to your question. Let me actually, I think we're running out of time. So let me meet you in person and I'll get more details from you.
Okay.
Thanks for attending.